Okay, this is the last option for restriction digest for the double digest. So it's the same question as before, and for the double digest, that's when you do one restriction digest, heat it up, kill the enzyme, and then do a second restriction digest using the same DNA. In this option, what we're going to do is the first restriction digest, heat it up, kill the enzyme, then we're going to be using a second different buffer in adding the second enzyme, where in the last video what we did is we used the same buffer throughout and just changed the enzyme. So it's going to be the same as the last video, where we're going to start with the lowest salt concentration, and we do that because it's like cooking. It's easier to add salt and then take it out. So we're going to start with BAM-H1 because it's 100 versus 150, and our stock concentration of salt, remember, is 1 molar, which is the same as 1000 millimolar. So in this one, since we are using the Sol-1 buffer along with the enzyme, we don't have to buffer the second part of the reaction. We only have to buffer the first, which forms the BAM-H1. So the first restriction digest, the total is going to be 22 microliters. First restriction. And this is at 100 millimolar salt because it's with the BAM-H1. Okay, now we only have to raise this volume because the second volume, the second restriction digest, is going to be at 150 because we're using the Sol-1 buffer. So that means we have to raise 22 microliters by 50 millimolar salt. So the same thing we did before, I'm going to do it again just for clarity. It's the 1 in 10 dilution of 1 molar, 1 molar NaCl, which is same as 1,000. Move the decimal point over so you get 100. Okay, so we have 100 millimolar salt there with a 1 in 10 dilution, but remember we only want to raise it 50, so divided by 2 is equal to 50, and so that was a 1 in 10 times a 1 in 2 is equal to a 1 in 20. So here we know we have to do a 1 in 20 in order to get 50 millimolar, but this is just a concentration, so we need to do a 1 in 20 dilution of 22 microliters in order to find out the microliters needed of salt to raise the first 22 microliters to the optimal salt concentration for the Sol-1 enzyme. So what we're going to do is do 22 microliters times 1 in 20, and that gives you 1.1 microliter of NaCl. So that means you have to add 1.1 microliters of salt into the 22 microliters of your first restriction digest, and then that's fine. You're at 150 millimolar salt, which is the optimal concentration for your Sol-1 enzyme. And another way to determine the dilution, that you have to do a 20 dilution, you can just take the molarity of your salt, which is 1,000 millimolar, divided by the molarity that you need to increase, which was 50. And remember that just came from up here, which is the 100 to 150, so it's 50. So 1,000 divided by 50 is 20, which means you need to dilute it 20 times.